Section 4.6, Formulas. A formula is an equation that contains two or more variables. So if we have any equation that has two or more variables in it, we're going to consider that to be a formula. So typically we think of a formula as maybe more of a geometric formula, and some examples of that I'll put down here, and then we'll come back up and do this problem. A few formulas that you'll want to remember when you're doing problems in this section and through the rest of the book. Perimeter of a rectangle. So we can kind of sketch some of these out. So if you had a rectangle, you'd have a couple widths to that and a couple lengths. The perimeter means to add your way around. So if you went around that adding them up, you'd have two W's and two L's. So the perimeter of a rectangle is 2L plus 2W. The area of the rectangle is length times width. Use an A for that one. So just real quick comment on the formula idea. There's 1, 2, 3 variables in this one, 1, 2, 3 in this one. So when you have more than one variable, you're considering that a formula. I'm just going to go ahead and throw the other ones out here for you as a reminder real quick. For the area of a triangle, that's 1/2 the base times the height. Get some quick pictures to go with that as well. So if you had a triangle and this was the base and this was the height, then the area is 1/2 base times height. Area of a trapezoid, trapezoid has two parallel sides and two that are not. Sometimes we might call this the big base and the little base, and then we have a height as well. And the area of a trapezoid is 1/2 times the sum of the two bases, so big B plus little b, times h. Area of a parallelogram. Parallelogram has opposite sides parallel to each other, and we have a height to that, and we'd refer to this as the base. And a lot like a rectangle, the area of the parallelogram is just base times height. Circumference of a circle and area of a circle, a couple formulas that we're going to look at. If you have a circle, the distance from the center to the edge is referred to as the radius, and the circumference of a circle, we'll use a C for that, is 2 times pi times the radius, and the area of a circle would be pi times the radius squared. Just a quick comment on pi. Typically we'll say that pi is approximately 3.14 is probably what you're used to. But if I bring the calculator in here for just a moment and we look at above this arrow key, there's a pi symbol. And if I hit second and pi, I'll get the pi key on the calculator, and if I press enter on that, instead of just 3.14, I get a more accurate approximation, 3.141592654. And pi, of course, goes on and on beyond that as well. But when you're doing problems and you need to put pi in as part of your calculation, instead of putting 3.14, use your pi key to get a more accurate approximation. Alright, let's go ahead and go back up to the top now and try and work on an area and a perimeter. They want us to find a formula for the perimeter for this and find a formula for the area as well. So we'll consider that like two parts. So part A, find a formula for the perimeter. Part B, find a formula for the area. So for perimeter, we just want to do the distance around. I'm going to make some assumptions here that I think were intended with this picture. One is that that would be straight across right there. The other would be that all these angles we see are right angles. So to start our journey around, we want to be able to know what every side is and add them up. So there's a missing side right here, but it should be the same length as this one. So if this is C right here, then this one right here should be C also. Kind of continuing around, the next thing that's missing is here. That's the toughest one. Let me leave that for a second. This one is also missing, but it's the same as this one. So this is E, so this side over here is also E. And then filling in across here, the length of this one would be the same as across here. If this is B down here, I'm going to do this in a different color because this dotted line indicates this isn't really a side, but this length of this dashed line would be the same as this down here, so this would be B. So how far is it across the top? You'd have to add up these three pieces, so it'd be A plus B plus D, but then this part across the bottom is the same, so this would also be A plus B plus D to go all the way across right here. Alright, so finding a formula for the perimeter, part A, the perimeter would be adding our way all the way around. So I'll just start here, head that way, go all the way around, adding up the sides. So the first side is A, and then I have C, and then across the bottom right there would be B, and then back up, C, across, D, down this edge would be E, extend this down a line, across the bottom, A plus B plus D, and then finally back up the left-hand side to kind of finish the loop right there, so plus E. So what's my formula for the perimeter? Oh, let's see, how many A's did I get? 2. There'd be 2 A's. I'm going to go ahead and check those just so I know what I've counted. And then the B's, there's 1, 2 of those. How many C's? 2 of those. I think I see a pattern. How many D's? 2 of those. And how many E's? 1, 2 of those. So it looks like the formula for the perimeter of that shape would be 2 A's plus 2 B's plus 2 C's plus 2 D's plus 2 E's. Alright, so let's go ahead and move on to the second part, which would be to find a formula for the area. And here's my strategy on this. That shaded shape is not one that I would recognize, but if I draw a line, let's say right here, and another line right here, then I'm going to break this up into 3 shapes. I'll call this area 1, area 2, and area 3. And what I want to do is add those together. So I'm going to say that the area would be the sum of those 3 that I've indicated. And then I'm going to try and figure out individually what is each one of those and then add them all together. So area 1 is a rectangle. Length times width looks like it would be A times E. Across A, down is E. So that first piece is A times E plus, second piece is I think the hardest one. Let me go ahead and go over to A3. A3 would be D times E, so I guess I did these in the other order, or I'm going to, so let me change that to a 3 and a 2 just so it all matches up. So for A3 that would be D times E for its length times width. And then the toughest one is this segment right here. So across is B, but how tall is it? So here's my argument. If this side is E, then this whole side is E also, but I don't have the C part. So this piece right here would be this whole length E minus this part up here, which would be C. So I think the area of that little piece right there would be B across and then times E minus C. And my apologies, I put an equals right here, but that's really just our third area that we're adding in, so that would be a plus sign. And then we'd have the distributed property right there. Looks like I'm running out of space a little bit. I'm just going to switch colors here so my formula stands out. So let's see, what's my area? I have an AE plus a DE. When I do the distributed property, I also get a BE, and then because of the minus, a minus BC. So there's the formula for the area right there. And again, breaking that up into the 3 pieces, one of which was a little tough because this side wasn't labeled, and I had to take the whole length E minus the part I wasn't using to give the part that I really wanted. Alright, continuing on in section 4.6, let's go ahead and look at some more examples involving formulas. So a rectangle has a perimeter of 88 inches and a length of 25 inches. Let me go ahead and label both of those. So they're telling me the perimeter is 88 inches and the length is 25 inches. And then they want me to find the width of the rectangle. So let's see, they gave me perimeter, so let me write down a formula for perimeter. Perimeter is 2L plus 2W. So there's my formula, but I know the numbers for 2 of those. The perimeter is 88 and the length is 25, so I'm just going to substitute those in. For the P, 88, the L gets a 25, and the W is still a mystery, so I'll just leave that as a variable. And now I have an equation that I can try and simplify. Simplifying both sides, 88 equals 2 times 25, which is 50. Trying to get this W by itself, so subtract 50 from both sides. That takes me to, let's see, 88 minus 50 is 38, equals 2W. Want that W by itself, so divide both sides by 2. and I get W equals 38 over 2, which is 19. And then what does that represent? The width of the rectangle, and the measurements on the other pieces were inches, so this would be the same. So the width is 19 inches. Alright, let's try another one. The surface area of a closed rectangular box is given by the formula S equals 2WL plus 2WH plus 2LH. Find the width of the box if S equals 76, L equals 2, and H equals 4. So this is the same idea as that last one, except for they gave us the formula instead of me having to make it up. And then they've given us several values, so I just want to start writing this formula down, but plugging those in as I go along. So S is given, so I'm going to substitute a 76 right there. And then for 2LW, let's see, what are we trying to find? The width. So that means the W is going to remain a mystery. But the L is 2 plus 2WH, but H is 4, plus 2LH, and we know both of those. L is 2 and H is 4. So I substituted in all the ones they gave me, and now I just want to start trying to simplify that. So 76 is 4W, just multiplying the 2's together, plus 8W, same deal with the 2 and the 4, and then let's see, 4 times 4, so plus 16. So I'm going to do two steps here at once on this next one. I'm going to subtract 16 from both sides to get the constants on the left and leave these W's alone. These are already on the same side, so I'm just going to go ahead and combine those. So these cancel. 76 minus 16 is 60, and then 4W plus 8W would be 12W. And then we're almost through there. Just got to divide by 12 to get the W by itself. Do that on both sides to keep things balanced. And so it looks like W equals 60 over 12, which would be 5. And I'd like to put units on that like I did on the last one, but they just gave me numbers for these, so I don't know if the units are feet, miles, inches. It's not clear, so we'll just leave that as a number, which is okay because that's the way they gave us the other one, so that's consistent. Would have been nice to know the units, but they didn't provide them, so that's all we can do. Alright, let's go ahead and look at another example. This one's still going to be a formula, but this one's different because it's not a geometric type of formula. They want us to find a formula for the total sales in dollars of selling N guitars at $895 per guitar. So generally at this point in the class, if we're going to build an equation on our own or a formula on our own, since we really only have been working with linear equations, we should probably expect it to be that type. So I'm kind of thinking I'm going to write something of the form y equals mx plus b, but my variables are not x and y. They are t and n, and I just have to think about which one is the input and which one is the output. So one of the things we could do to help us with that would be to find the slope. So right here I see the word per. That's usually a good indicator that I've got my slope. So I think this is slope right here, $895 per guitar. That's change in output over change in input. So which are those? Well, it's dollars up top and guitars on the bottom. So it looks like the bottom part is N, the number of guitars, and the top part is the dollars or the cost. So that would be change in T. This is my input variable, that's my output variable, so it looks like my equation is going to be of the form T equals M times N plus B. And we already said M right here is 895. So now we're just thinking, well, what's the B? Remember, B is the y coordinate of the y-intercept, and it always goes with an input of 0. Well, how much should it cost to buy 0 guitars? If this is going to make sense at all, we wouldn't pay any money if we're not buying guitars. So I think in this case, our B is 0. So if we were to plug that in, 895 for M and 0 for B, we get T equals 895 times N plus 0, and the plus 0 just makes this look like unnecessarily messy. That would just cancel off or just go away, so T is equal to 895 times N. Feels like the formula. And then they didn't ask us to use it, but at this point if they told us how many guitars we had, we could plug it in here. If they told us how much was spent, we could plug it in here and solve for the number of guitars. But we have a formula that's set up and ready to go. Alright, continuing on with section 4.6, let's look at another example. This is another geometric one, but this time it's not a shape that looks totally familiar. So we're going to, I mean, it looks familiar in the sense that it looks like a track, but it's not a circle, it's not a rectangle. It's a combination of those two things. So let's read through it. A running track has straight legs of length 100 yards that are 60 yards apart. What is the length of the inner lane of the track, including the semicircular legs? And what is the area of the infield of the track? Round both of those answers to 2 decimal places. So there's 2 answers here, so let me go ahead and label that first, or 2 questions here. Let me label the first one as A, and then this next one as B, and then we'll work on each one of those individually. So what's the length of the inner lane of the track, including the semicircular legs? So they're saying if we were to run around, like maybe we start here and we ran around the whole thing, how far would that be? So let me do some chopping here. I'm going to do a chop right here, which represents this distance of 100 yards on one side and also on the other. So I'm going to make that same chop. If you look at what's on the inside of that, that would be a rectangle. And then it may not look quite like it in this picture, but they said on the outside those are semicircular legs, meaning half circles. So if I took this half and that half and were to slide them together, that should make up a complete circle. So if we were to run around this, we would run how far? Well, let's say we started here and then started running this way. Well, we would run 100 yards right here, and then we'd go around half a circle, and then we would be running this way now, and we'd go another 100 yards and then another half circle. So if I'm looking at part A, how far did I run? So let's see, they just said what is the length, so I'll use an L for that. The length of that would be 2 times 100, because I'm running 100 across here and then 100 here, and then plus half a circle here, and then plus another half a circle on the other side. And so rather than add a half a circle and a half a circle, just think about that. You have the 2 halves. That's going to be 1 full circle. So the length should be 2 times that 100 plus the circumference, because we're going around the outside edge of 1 circle. So a couple pages back we said the circumference of a circle would be 2 times pi times the radius of that circle. So the piece that's missing at the moment is the radius of the circle. So this is 60 right here. So that means this is 60 and this is 60. This is the distance all the way across. So if we went here and went at an angle, that would be the radius. But then this would be the radius, this would be the radius, this would be the radius. So any line from the center to the edge would be the radius. So since all the way across is 60, that means we have 30 here, 30 there, and that means all these other ones would be 30 as well. And that means that the radius of the circle is 30. So let's plug that in, and we would then have 2 times 100, so 200, plus 2 times pi times the radius, which we just figured out was 30. And if I wanted to simplify that a little, I could do the 2 times the 30 is 60, and say that the length ends up being 200 plus 60 times pi. And if we were doing this in a pure math class, we'd probably leave it that way because it's exact. But if we look at our directions, they want us to round the answers to 2 decimal places. So I'm going to put this into the calculator and give a rounded answer. So let's see what that answer would be. So bring in the calculator. Just a reminder, I said when you're going to use pi, to use this pi button. So I'm going to do 200 plus 60 times second and pi. And I get 388.49555, but they said to round it to 2 decimal places, so that would be 388 point. It's a 49, but followed by a 5, so that 5 would cause me to round this 49 up to a 50. And now I have the number, and I just want to think about the units, so I just go look at the units they gave me. All those other measurements were yards, 100 yards apart, 60 yards across, so everything was in yards, so this will be in yards as well. So 388.50 yards. And this is talking about a distance, so it wouldn't be yards squared or yards cubed or anything like that, just yards. Alright, so that takes care of the length around the inner lane of the track. Now let's work on the area of the infield. So the area of the infield is going to be the same strategy. I'm going to break it into a couple pieces. So looking at the picture, one of the pieces would be this piece right here, which is just a rectangle. And the other piece would be the two semicircles. So I have this half right here plus this half right there. So it looks like the infield is made up of a rectangle and two half circles, or if you slide those halves together you can say there's a circle and a rectangle. So when I go to find the area is going to be the area of the rectangle plus the area of the circle. And so the area of a rectangle would be length times width. The area of the circle would be pi r squared, and I want to just plug in all those numbers. So taking a quick look at the rectangle, length is 100, width is 60. So I'm going to have 100 times 60 for that rectangle piece out front, plus pi times the radius squared, and we determined when we were doing part A the radius is 30. So I'm going to have a 30 squared. And I'll go ahead and do the simplification on this, and then we'll go to the calculator. So the area of the rectangle, 100 times 60, so let's see, 6 times the 1 would be 6, and then 3 zeros, so that'll be 6,000, plus 3 squared would be 9, so 30 squared would be 900 times pi. And then at this point I'll go to the calculator and get an approximation, which is what they want from me. So let's see, 6,000 plus 900 times pi. And I get 8,827.43, and that's followed by a 3, so it would round down to the 0.43. And the units were yards on everything, but this time we're doing area, so right here this is 100 yards times 60 yards, so that would be yards squared. This was 30 yards, and then we squared it all, so the 30 got squared to give 900, but the yards would get squared to give yards squared. So as we would expect on an area problem, we're coming up with square units, so 8,827.43 square yards, and then right here. And then just a quick comment on, why would we want to know these things? Well, if we were running the track, we'd want to know how far it was to do a lap. But the infield, maybe that's grass, and we want to know how much area do we have to mow if we're the gardener or something like that. Okay.